Hello friends. Friends, today we will discuss and derive wave equation in non-conducting medium in terms of magnetic field intensity H. Last time we have discussed wave equation in terms of electric field intensity. Today we will discuss in terms of magnetic field intensity. Last time I have told you what is the meaning of non-conducting medium. Non-conducting medium. That medium which is not conducting because there are no free charges available. Okay, so the first condition is that is conductivity is 0, so J is equals to 0. Okay, that is conduction current density is equals to 0 because that is equals to sigma into electric field. Second condition is rho is equals to 0 because rho is equals to dq by dv. Okay, that this thing I have discussed in the just previous video lecture. Okay, and now we will rewrite the Maxwell's equations here. Now first Maxwell equation is del dot E equals to 0. Del dot E is equals to rho by epsilon. Rho by epsilon. If it will be a free space, it will become rho by epsilon naught. Now if rho is equals to 0, then this is 0. This will be our equation number 1a. Second is del dot H equals to 0. This is equation 1b. These Maxwell equations I have derived all these Maxwell equations. So please see our playlist of electromagnetic field theory. Del cross E is equals to minus mu curly H by curly T. Equation number 1c. Del cross H equals to J plus epsilon curly E by curly T. Now J is 0. So this will be 0. So epsilon curly E by curly T 1D. Okay. So these are the four Maxwell equations we are going to use to derive the wave equation in terms of magnetic field intensity H. Okay. Last time we have taken the curl of 1C. Now take curl of 1D. Take curl of 1D. Okay. So it will become del cross H equals to epsilon curly by curly T del cross E. Okay, equation number 2. Now this is a proved result, vector identity, and this is equals to del cross H equals to del of del dot H minus del square H. Okay, so put this result here in equation number 2. So equation 2 will become del dot H minus del square H equals to epsilon d by dt del cross E. Okay, now what is this Maxwell equation, this result? Okay, this is second Maxwell equation, equation number 2. Okay, this is equation number 2, 1b, sorry, 1b, and this is del cross C is 1c. So del dot H is 0, so it will be 0 minus del square H. And what is del cross E? Del cross E is minus mu curly H by curly T. Okay, so minus and minus sign cancel out, so this will become del square H equals to mu epsilon d square H by dt square. So this is a wave equation in terms of magnetic field intensity H. Last time same equation was there, just instead of H we have derived E. Del square E is equals to mu epsilon curly square E by curly T square. Okay, so this is a wave equation in terms of magnetic field intensity H for a non-conducting medium or for a perfect dielectric medium or for a lossless medium, because if there are no charges there will be no losses, and we can write this equation for free space also. Just change mu with mu naught and epsilon with epsilon naught throughout the derivation. Okay, so you will get del square H equals to mu naught epsilon naught curly square H by curly T square. So I hope so you have understood the derivation of wave equation in terms of magnetic field intensity H for a non-conducting medium. Thank you. Thanks a lot.